Hi guys, I hope you're having a great day. Today we're going to talk about trends in graphs, also known as correlations. Let's review a couple of important things before we talk about trends. Remember the mnemonic tool dry mix. The X stands for the x-axis, which is here, and the Y stands for the y-axis, which is here. Remember that the manipulated independent variable causes the result of the dependent variable, which helps us remember that every time we look at a graph, the independent variable will be graphed on the or labeled on the x-axis, and the dependent will always be graphed on the y-axis. That is a simple rule that we always follow in science because remember, communication is key in science. The second important rule that we need to review is how to write a title for a graph. Remember, we always list the dependent variable versus the independent variable. The dependent variable should always be first. So if we look at the title that you guys actually had in one of your assignments last week, we have car speed versus stopping distance. Using the rule for titling graphs, if I were to ask you which of the variables in the title is the dependent variable, you should answer car speed because dependent variable always gets listed first in the title. Now, if we think about this then, since we know that dependent goes first, let's circle that one. Go back and make those match. The independent variable by this rule should be stopping distance. So now I want to ask you a new question. Is this a good title for a graph? Think about that. If my stopping distance is my independent variable, then it should cause the dependent variable because of what we've learned with dry mix. Remember that the dependent variable is the result of the manipulated variable. Okay, so if we go back to the car speed and the stopping distance, does it make sense that we say that the stopping distance causes the car's speed? Of course not. Why would this stopping distance cause the car to go a certain speed? A correct title for a graph that is comparing the stopping distance and car speed would be stopping distance versus car speed, because our dependent variable now is our stopping distance, which depends on the independent variable, the car speed. So we could say with this title, once we've identified the dependent and independent variables, car speed causes stopping distance. So not only can we use the rule for titling graphs to easily identify which variable is dependent and which one is the independent variable in the title, but we can also use that and apply that rule to determine if a title is an appropriate title for a graph or not. Let's practice titling some graphs. Look at graph number 1 in the upper left-hand corner. Remember that we title dependent variable versus independent variable. Take a minute and think about what you think that title should be. If you came up with a title similar to amount urea versus pressure, then you were correct. Remember that dry mix, the dependent variable, is on the y-axis, and that goes first. and the independent variable, mix, independent, goes on the x-axis. That always goes second. Let's look at number 2. Look at the axes labels and think about what you think a good title for graph number 2 would be. If your answer was miles per gallon versus car weight, congratulations. Let's do one more. Graph number 3. What would an appropriate title for that graph be? If you said GPA versus shoe size, great job. Now we're going to look at trends. Okay, graphs can have 3 different trends. You can have a trend like you see on graph number 1, where it looks like as you read it from left to right, because we always read graphs from left to right, it looks like the dots, the points are increasing, okay? If you look at number 2, that is actually a decreasing trend because from left to right, the dots move down, okay? And then number 3 is an example of no trend because the dots don't lead you in an upward or a downward direction as you look at them from left to right. They just look like they're scattered all over the place. We use graphs in science because they are pictures of data. We use them to figure out correlations between our independent and our dependent variables. What is the relationship between them? In graph number 1, as the osmotic pressure increases as we move from left to right, notice that the amount of urea increases. So it's a positive trend. As osmotic pressure increases, the amount of urea increases. We would read number 2 as the car weight increases, the miles per gallon decreases. And with graph number 3, we would say that there is no correlation between the shoe size of a person and their GPA. Look at this graph. What kind of trend do you observe on this graph? If you answered a positive trend or an increasing trend, you are correct. Remember that we always read a graph from left to right. So if we follow the line on the graph, it looks like as you go from left to right, start in the very bottom left-hand corner, as you follow the line, it goes up. So it increases or it's a positive trend. Notice that the line on the graph does not go through all of the points. When we draw a line of best fit on a graph, we can use it to write a trend statement, but it has to be straight in order to be able to do that. So a line of best fit is the best line that we can draw for the scatter plot or the points that are plotted. Notice that it does go through some of the points, but we have about the same number of points above the line as below the line. If we drew a line like this, that would not be a line of best fit because it doesn't fit the points that are graphed best. Same here. If I draw a line like this, that's not a line of best fit. The line of best fit is going to go through as many points as possible, but have about equal numbers above and below. We will go over exactly how to do that and review that in another video. With the line of best fit, we can write a trend statement. We will use that. We notice that as we go to the right 1 minute, the graph goes up and increases 10 centimeters. So I can use those numbers that I just figured out, 1 minute and 10 centimeters, to write a trend statement. So I'm going to start my trend statement with, for every 1 minute of time. Remember that the time is the independent variable, so it should be first in my trend statement because it is causing the change in the dependent variable. So for every 1 minute of time, distance from the nest increases 10 centimeters. Our trend statement contains some very important information about the graph. I don't even need the graph now. If I could just explain somebody what I discovered with my experiment in reading that trend statement. I know that the graph is an increasing graph. I know that for every 1 minute of time, the distance from the nest increases 10 centimeters. We went over some new information today. So as you complete your worksheet, you may have to come back to this video and re-watch some sections of it so that you can answer the questions correctly. Use these as your notes. Good luck.